Hello, this is Junichiro Horikawa, and today I would like to show you how to export a selected geometry inside a Grasshopper as a Rhino file or mesh file like FBX, OBJ, or so on, using a C# script. And to do that, specifically to do that, unfortunately, there is no exporting functions in Rhino common, I believe. So instead of using a Rhino common native functions, we're going to use the command that you often use right here, like export or export selected and so on. So we're going to access to this command using a C# script in order to achieve the exporting function inside a Grasshopper. So let's do this. And I am going to use this geometry as a sample geometry in order to export it as a file, like 3DM file or any mesh file. Okay, so before getting into the actual coding, let's think about the process, how we're going to use this export command. So first of all, in order to use the export command, you have to select a geometry inside Rhino. So first thing you might need to do is to bake the geometry that you want to export in Grasshopper. So this is the geometry node that has all the geometry that I want to export. So first, let's try to manually bake it inside Rhino like this. Then type a command called export, that which you want to use this time. Then it gives you an option, say select objects to export. So we're going to select those objects, then enter. Then we have to define the path where you want to save the file. I'm gonna name this sample 3dm. Now the file has been saved as sample.3dm on the desktop folder, like this. Okay, so and after you have exported the geometry, you no longer need those geometry inside Rhino, so we need to delete that. So that's the whole process that you want to do using inside a Grasshopper using C# script. So let's try to follow that process using a script. So we're going to bring up the C# script and let's give some parameters that we're going to need. First of all, obviously a geometry input in order to define the geometry that you want to bake, and we're going to set it as tree in order to access all the geometry inside from the input. So let's set it to data tree access. Then for the type hint, we're going to set it as geometry base. Okay. Now next thing, we would like to set the name for the file that we want to export. So let's name this file name, and let's set it to string as a type hint. Okay, next let's set the input parameter called directory where we want to save. This is going to be the folder path where we want to save the file. So for this one, string as well. Set the type hint to string as well. Then and last, we might need some Boolean input in order to trigger this function or trigger this component in order to export the export command. So let's have the input called export and set it as Boolean, and let's give some conditions inside the script. When the export condition is true, then do the export. When the export condition is false, then do not export the file, and so on. So that's the export is for that condition. Alright, so let's connect the geometry to the first input. Then for the file name, I'm going to say sample2.3dm as an example. for the directory, we're going to use the path node, connect it, and then right click to the path node, and there is an option called selected directly. So select that and choose a folder that you want to save the file to. So for this example, I'm going to save it to this sample folder on the desktop. Alright, I think it was on the desktop. Let me check this out. Yeah, it's under the desktop. Alright. Now let's also create a boolean toggle in order to activate this command in order to export the geometry. Right, currently it's set to false. Alright, so after we have set it up the input, maybe we might also want to set up the output, but since this component is just to export the geometry, we don't need any output, so I'm going to delete the output A. You can keep the out for debugging maybe. Right, so after setting up the input and output, let's double click and get it into the code editor to actually write the code. Right, so first of all, we would like to set the condition using export. So let's try to run the code only if the export boolean is equal to true. Right, then the first thing you might want to do is to bake the whole geometry, which is coming from this geometry's input, which is equal to data tree, which has the data tree structures. So first thing you want to do is to get all the geometries from this data tree structures and bake them inside the Rhino. Then get that information, use that information to select those baked geometries and export those selected geometries using an export command. So let's bake the geometries. In order to bake the geometries, first thing we want to do is to access all these, access each geometry inside the data tree. So let's use the for loop to access all the geometries. First of all, we need to access the branches of this data tree. So we're gonna type geometries. Am I typing correctly? Okay, this has a spell mistake. Let me go back and type it back. Geometries. Right. Okay, let's go back and geometries dot. So in order, first of all, we're going to loop through the whole branches using branch count. Then, and this is going to be the first loop. Oops, I need a parenthesis here. Okay, now we also need a second loop in order to access on each branches. Since the data tree is kind of a nested loop, we kind of need to do a nested for loop in order to access all the geometry items inside data tree. And for each branches at I index, each branches is equal to a list. So finally we can access to a geometry inside each branch. Geometries, branches, I, N. So this is the geometry that you can get from each data tree branches. Right. Now let's bake this geometry on top of the Rhino canvas, and to do that you can access to the active document of Rhino by doing like this: Rhino doc active doc. So this is the active document of the Rhino, which is running right now, like here. And then access to the object table by typing objects, then say add and inside add you can just use this geom to add the geometry base. So this geometry base could be anything like curve, point, surface, mesh, VREP, and so on. Right, and as an output, well, this itself can generate or bake the geometry on top of the Rhino, but as an additional information, this command will give you a GUI information, and we need that in order to select the baked geometry later on. So we're going to retrieve the grid like this, and we're gonna store it in the list later on. Okay, but first of all, we would like to check if the baking is doing okay, is working. So let's click this play button to check there's no errors, and then type OK. And in order to check the functionality, we can toggle this Boolean toggle and see if the geometry has been baked. So let's double click, and yes, successfully the geometry has been baked. Input geometry has been baked, and I think there's no duplicate. Okay, looks good. Let's delete this and set it to false and go back to the coding. Now as I said, we need to store all those GUID information, which is a unique ID for each geometry that you have just baked on a Rhino. So, and we're going to use that to select the baked geometries later on. So we're going to create a list storing all those GUID informations like this. It always just convert to light when I try to use list. Okay, now I have an empty list storing GUID information, and after we have retrieved the GUID by baking the geometry on the Rhino, we're going to add this GUID inside this list like this, right? Now, after retrieving or after baking all the geometries, what we want to do next is to select all those geometries that we have just baked. To do that, we are going to access the same documents, same objects table that we have done here. So let's just copy these line, and then paste it right this, and then under the objects table there is a command or function called select, and this select function can select single object or multiple objects. If you want to select the multiple objects, in this case all those geometries that you have baked, you can use a list of GUIDs as a parameter for the select in order to select all the geometries. So I'm going to put this GUID list inside a parameter for the select, and let's see if this will select the geometry, selected baked geometry. So go back to the Grasshopper document canvas and then double click this. Yep, now as you can see, the baked geometry has been selected like this. Now I've just deleted, and it's pretty close to the ending. The only thing we need to do now, or maybe the last two steps you need to do, is to export the geometry that you have selected with this command, with this function. Then after you have exported, you just want to delete the geometry which you don't no longer need it inside the Grasshopper. So let's and in order to export the geometry, we want to access this command called export, like this one. So how do we do that? How do we access to the Rhino command? We can use a function called rhinoapp.runScript. So this is the function that you can use to run the command inside the C# script. And inside this parameter, you want to type in the actual command string, command text. So we need to create this command text beforehand in order to use this one. So let's create some command script or command line. Okay, and in order to save the file, in order to use the export, let's check what kind of parameter we would need in order to export. So I have just created a simple object like this, and let's use export. And you see that the first on the first dialog you'll see some saving dialog in order to determine the path where to save and what the name of the file. Set the name of the file. So if I type it sample.3dm and save it and replace it, you can save it. You can save the 3dm file. And if I export it to a different geometry type like meshes, like if I try to export the geometry to obj mesh, then it will give you another kind of dialog which looks like this in order to determine, or in order to specify the exporting quality of this mesh, like this. I'm just gonna set it as default and say OK, and as a result you should be able to get this exported object. Now we want to do the same things in scripting. When access, we want to just set the parameters for each option that we have just shown using a command line, but do the same things in script. So in order to use the script or command line inside a script, as you might have seen, first thing you have to have the path information where to save the file. So let's create that first. So string file path, and actually we have this file path information already from the input of this Grasshopper node or component, which can be created using two information, file name and directly. So we're going to combine those two strings to actually get the file path. Now, combining those two informations like path and file name, the best practice in C# is to use a system.io namespace right here, and inside this namespace there is a class called path, and there is a static function which calls combine, and this path.combine can create or concatenate this directly in file name. So for first input, first parameter, I'm gonna set it as directory, and for the second second parameter, I'm gonna set it as file name, and this will give you the concatenated file path out of these two information. Okay, now it's time to actually write the command using a string. So the command that we want to access is called export. So first we going to type like this, _-export space, then close the string with the double quotation. Then we're going to, the first parameter for this export will be the path information. So first of all, let's escape this double quotation to create a double quotation inside a double quotation as the double quotation as a string. Then add the file path that you have just created and do the close this file path with the double quotation again. Then after this, if it's a 3dm, you can just enter to finish the export. If it's a mesh, there's going to be another parameter that you have to enter, but we'll see that later on. For now, we're going to deal with the 3DM export. Right. Now we have just created a command text in order to export the file. What we need to do now is to actually run this script. And this is where you can run the script that you have just created. So cmd is the name of the string of the script, and for the second input, you can set the boolean whether you want to echo the script or not. Basically, I think you don't need to echo the script. I think echoing the script is kind of a debugging purposes a lot of time, I think. So we're going to set it as false. All right. And let's check this out. Okay, so see if there's no errors, say okay. And so the name that we want to save is sample2.3dm inside this sample folder on the desktop. Now we don't have a sample2.3dm at this point, but let's see if I double click this toggle. Double click it, and say, let's see if anything has happened. And yes, the sample2 has been created. So let's delete this geometry and import what we have just created, or what we just exported, to see if the geometry is the one that we have just exported. And yes, it seems like so. So the exporting is successful. Let's set it to false. Now the last thing we want to do is to delete the selected geometry that we have right here, that we have just selected, so that there's not going to be any like garbage left inside Rhino, because this is for the Grasshopper operations. We don't need to have any big geometries after exporting. So to delete the geometry, it's pretty much similar to this line. We access the object table, then there's a command called delete, and we can set the same grids, the list of grid. And for the second parameter, you can set the boolean whether you want to delete the geometry quietly or not. And most of the time, I think you want to delete it quietly. So let's write it like this, and let's try the command again. And let's try to rename this to 3. And let's say true. And there's no geometries left inside Rhino. And if you go to the folder, there's a file name called sample3, like this. Okay, works. Brilliant. Alright, so exporting 3DM works. Now let's also try to export it as other extensions, as a file extensions. This should work for any extension that Rhino supports, like iges could also work, or 3ds might work as well, obj, stl, fbx, and so on. But when it comes to obj or stl, those kind of mesh geometries, there's a big chance that you have a second parameter after setting it directly. So let's check that out. If I change this to sample3.obj and double click the toggle, you see that the command has stopped, and there's a command line saying choose meshing option. And actually, when you try to export the geometry to mesh, you have to kind of define how the resolution of the geometry, resolution of the mesh, how much detail the mesh you want to export as. So And after you have set some parameters, after you have chosen the options and re-enter, then the whole script will run again. And then you see this obj that you have just exported. Now if you want to skip the option part, or if you want to set the option parametrically, you can, if you know that you are exporting as a mesh, you can type additional queries like when, let me check this again. So when you say true, so there's two options when you export into meshes, so detail options or polygon density. So if you want to go into the detail options using the command, using the script, then let me escape this command for now. Then what you can do is to go into the script again, then type D like this, and then say OK. And let's try to toggle this up again. Now that you see that the option has been selected already using that command query, and get it into another option that you see like this. So if you want to specifically define the mesh options, you can check the letter with the underscore right here, and then type that as a command. But for now, I just want to export it as a default option, so I am just going to say enter. And this also still works with 3DM as well, because after you have exported, having an additional enter will just mean re-entering at the empty command as well, so it doesn't really make any difference. Okay, so let's say OK. Now let's try this again. Right, so currently you have sample3.obj. If I set it to true, everything works flawlessly. Right, and let's also try with the 3DM. If I set it to true, it should also work, I guess. And you have this sample3.3dm, which is exported at current time. So it is working. So that's it. That's how you can export the geometry using a C# script by using a command line with the RunScript function. And as you can see, this function can be used for any other command that you can use right here. So it's not limited to just export, but it can be used for all those commands that you have in Rhino. So it's really a versatile skills that you would like to learn, would like to know. Right, so that's it. Thank you very much, and see you next time.